Welcome to Fluid Coding and AI. GLM-5.1 is being pitched as a model that can work for hours on one engineering task, not just answer one request. That turns the question from, can it code, into something harder. Does it keep getting better when the work gets messy? The claim worth testing is not that GLM-5.1 always beats Claude, Qwen, Gemini, or GPT on coding. Z.ai's own table does not say that. The claim is more specific. GLM-5.1 is designed for long-horizon autonomous work, where it plans, executes, tests, fixes, and optimizes instead of stopping after the first plausible solution. If that is true, the score should improve after the obvious first patch is done. Developers already use AI coding tools, but trust is still thin. Stack Overflow's 2025 survey says most developers used or plan to use AI tools, while only 29% trusted AI accuracy. Sonar Source's 2026 survey discussion says developers still do not fully trust AI-generated code to be functionally correct. That is the real pressure point. Almost right code can cost more than obviously wrong code. Z.ai describes GLM-5.1 as its latest flagship model for long-horizon tasks. The docs say it can work autonomously on a single task for up to 8 hours through planning, execution, iterative optimization, testing, fixing, and delivery. The model card and repo also frame the upgrade as moving beyond first-pass performance. Earlier models can get quick gains and then plateau. GLM-5.1 is claimed to keep revising strategy over hundreds of rounds and thousands of tool calls. The specs explain why this is not a laptop default model. Z.ai's docs list a 200,000 token context and up to 128,000 output tokens. The GitHub table lists GLM-5.1 and GLM-5.1 FP8 as 744 billion parameter, 40 billion active MOE models. That is open availability, but not lightweight deployment. Self-hosting still means serious serving infrastructure. Z.ai reports GLM-5.1 at 58.4 on SWE Bench Pro, 42.7 on NL2 Repo, and 63.5 on Terminal Bench 2.0 with the Terminus 2 setup. The same table lists Claude Opus 4.6 higher on NL2 Repo and higher on that Terminal Bench setup. So the published evidence is not a clean victory lap. It is a claim that GLM-5.1 belongs in the frontier conversation, especially when the task rewards sustained tool use. For a fair story, GLM-5.1 needs two foils. Claude Opus 4.6 is the launch-era closed frontier comparator because Z.ai compares against it directly, and Anthropic also describes Opus 4.6 around long-running agentic coding. Qwen 3 Coder 4ADB A35B. Instruct is the cheaper open comparator. Qwen presents it as an agentic code model with open weights, a 480 billion parameter mixture of experts design, 35 billion active parameters, and repo scale context. A normal coding demo asks for a feature, waits for a patch, and checks whether the tests pass. That misses the exact thing GLM-5.1 is claiming. The system's test needs a repo with cross-file coupling, failing tests, one intentionally slow path, and enough ambiguity that the model has to form a plan. Then every model gets the same tools, time limit, log budget, and stop rule. The benchmark claim says the longer it runs, the better the result. So we should not grade the first answer. We should grade the slope. Track first working test pass time, final test status, best benchmark score over time, cost to first pass, cost to best result, repeated commands, recovery loops, and strategy changes after reading evidence. A model that improves after test failures is different from a model that only edits more files. The first checkpoint is planning quality. Does the model inspect the repo before editing? Does it identify the files that own the behavior? Does it connect the failing tests to the performance target? This matters because long-horizon coding can look productive while it drips. A clean plan is not proof of success, but a weak plan usually predicts wasted commands later. The most useful moment in this kind of test is the first failure. A model patches something, runs the tests, and gets a red result. Now we learn whether it reads the error carefully, narrows the cause, and changes strategy. That is where an agent stops being a code autocomplete demo. The model has to treat the terminal as evidence, not as background noise. The second checkpoint is performance iteration. Z.ai gives examples where GLM-5.1 reportedly performs hundreds of optimization rounds, including a vector database task with 655 iterations and a claimed 6.9 times throughput improvement. That kind of claim needs a curve. Did the model find a real bottleneck, measure it, improve it, and avoid breaking correctness? Or did it chase noisy benchmark changes? Long horizon agents multiply cost because they read files, run tools, inspect logs, and carry growing context. Z.ai's official pricing lists GLM-5.1 at $1.40 per million input tokens and $4.40 per million output tokens. Anthropic listed Opus 4.6 at $5 input and $25 output per million tokens. Qwen 3 Coder can be cheaper again on common providers, but the cheapest token price does not win if the agent loops. Benchmark numbers are scaffold sensitive. SWE, Bench Pro, Terminal, Bench, Claude Code, Codex, Terminus 2, effort settings, private splits, public splits, and context compaction can all change what a model appears to do. That does not make benchmarks useless. It means the harness is part of the result. If GLM-5.1 needs a strict test loop to shine, that is useful engineering information, not a footnote. SWE Bench Verified is useful because it uses real GitHub issues, but it is still not the whole long horizon story. Terminal Bench adds terminal environment tasks across software engineering, machine learning, security, data science, and more. NL2 repo asks for a whole repository from natural language requirements. Together, these benchmarks point at the right failure modes: premature stopping, loss of global coherence, fragile cross-file dependencies, and inadequate planning. A strong GLM-5.1 result would look like this: slower or similar first pass, fewer repeated loops after failures, a visible benchmark curve that keeps improving, and a lower cost to best result than the closed frontier model. An even stronger result would show it changing strategy because of evidence, not because it was told to persist, but because the tests, logs, and measurements proved the old approach was wrong. The practical verdict is conservative. Treat GLM-5.1 as a serious long-horizon coding candidate, not as a proven replacement for every frontier coding model. Its first-party numbers put it near Opus class comparisons on several agentic benchmarks, but they also show losses depending on the suite and harness. The right way to test it is not vibes and not one cherry-picked demo. Give it a repo, a wall clock limit, a dollar limit, tests, benchmarks, logs, and a score curve. If this helped you think more clearly about long-running coding agents, like the video and subscribe to Fluid Coding and AI. The next useful question is not which model sounds most autonomous. It is which one keeps improving when the tools push back.